The motor is the heart of the treadmill. The motor rotates the belt as you walk, jog, or run. The motor not only moves the belt, but it must also overcome the resistance of each stride. One of our field application engineers recently visited a customer that was using a 4-horsepower, 220-volt AC induction motor to drive their treadmills.
Treadmill applications present an interesting control problem. Treadmills have to operate across broad speed and load ranges. For this treadmill application, the speed range varies from 42 RPM at the low end to 3,300 RPM at the top speed. The load range can also vary from less than 100 pounds to several hundred pounds. To emphasize this control challenge, one of the engineers stood on the belt while the speed was set to 100 meters per hour. Another engineer placed a foot on the belt, demonstrating that the motor had difficulty overcoming the additional resistance. Once the treadmill was controlled by InstaSpin-Motion, there was a visible difference in performance. One of the engineers stood on the belt while the machine was operating at 100 meters per hour. The engineer then applied an opposite force to the belt by grabbing the handrails.
Wow, that's pretty impressive. Before we applied InstaSpin-Motion, the engineer was able to stop the belt from moving just by putting his foot on the belt. Now, when the treadmill's under the control of InstaSpin-Motion, the belt continues to move even when the engineer applies his entire weight to stop it.
If we compare the existing design to a design using InstaSpin-Motion, the customer can solve their low-speed control issues, the tuning time is reduced to almost nothing, and they can eliminate the cost of the drive and the cost of the sensor.